2 wheels, 2 triangles, human-powered. Strava, a popular cycling app, reported some impressive statistics in 2020. Those numbers have also a positive impact on our planet. Good for you and good for the planet. It's called win-win. But for most of us, the idea of riding to the grocery store, work, or even around the block is just hard. Pedaling takes work. But what if it was easier? Today, electric assist bicycle e-bikes are becoming common for a growing audience. Looking closer at the global e-bike market size in billion views, it's easy to see why the industry leaders, along with new names in the cycling industry, are all jockeying for their piece of pie. With a 9.6% compound annual growth rate, this industry is projected to reach over $40 billion by 2030. That's impressive. So, how do we get there? We have to integrate the extra complexity of a battery, a motor, and a control circuit. Today, we'll see how that can be done utilizing the tool available on the 3D Experience platform. Using design techniques and leveraging outside suppliers, we'll take on the challenge of building a frame to accommodate on the industry standard drive system. We will see the process of reference a battery supplier to build an appropriate cutout into a bike frame, ensuring proper fit, form, and function, and tracking all critical components along the way. Of course, those batteries undergo critical thermal and drop test loading, which can be virtually validated during the design process. Using best-in-class simulation tools on both desktop and cloud-based solvers, we'll see how the 3D Experience platform can virtually validate dynamic analysis, such as structural and life cycle loading. Of course, the ever-evolving lithium-ion industry is finding ways to make batteries smaller and lighter, which will need to be considered into the design intent of this bike frame, making sure downstream modifications are controlled through the proper versioning and involve little redesign efforts. We will tackle all of those challenges through today's conversation around the 3D Experience platform, starting with the project kickoff, which requires multiple team members to tackle individual tasks built throughout a project plan. We will dive into the design of the e-bike's frame using the 3D Experience SolidWorks Connected and validate the design durability along with dynamic validation. And with the complexity of the board computer and large lithium-ion battery, electromagnetic interference needs to be a forefront. Then we will wrap it up. This is a pretty substantial checklist, and I wouldn't expect an individual to take it on. So let's meet the team working with our battery and motor supplier. Salil is the analyst, loves to take on complex problems. Lorux, project engineer, will keep everything in check and delivered on time. And finally, Bruder, his primary focus is creating great designs. The battery and motor supplier will be collaborating with the bike frame supplier. The key team members involved here are Taylor, simulation engineer, and Anik, head design engineer. Because those two groups will be working tightly together, keep an eye out for the demo on how the 3D Experience platform seamlessly incorporates the two through design and engineering collaboration, project tasks, simulation results, and more. We have met the team and seen the overall timeline. Now it's time to dive in. Everyone will be involved with the initial project kickoff, which can be hosted through the 3D Experience platform, taking advantage of the free Rin role. Lorux, the team project manager, logs into the 3D Experience platform through a web browser. Through the 3D Lean role, she accesses a team board, which gives her and everyone access to a virtual whiteboard. Here, she sees a matrix of projected and program information, including 2D images, website links, sketches. This board can be implemented through collaborative efforts of all stakeholders through the life of the project. 3D Lean also supports 3D models. Here, Larux reviewed the current 4-cell battery design, slated to be integrated into the new eBike, and possible a 3-cells design that is under review. Lean boards can be used to capture ideas and later be leveraged to present back to other project stakeholders. With the first major task communicated back to the broader team, the design engineers have their work cut out for them. 3D Lean was a perfect way to articulate those requirements through virtual whiteboards and gives remote teams a lean and efficient method of virtual meetings. With both 2D and 3D supports, those lean boards offer limitless possibilities. Agile project management is an efficient way to capture requirements and collaborate on ideas. Now it's time to put those actions into a project plan. Larux navigates to her next slide and opens the toolbar in 3D Lean to start capturing sticky notes. First task, the battery needs to be validated. This action item is added to the to-do column and assigned. Taylor's avatar is placed on the action item along with a sticker to reinforce its urgency. A second task is created, outlining the design integration needs. Repeating the process of adding to the do column and assigning out to Ankit. As the team knows, physical testing plays a huge role in a proper bike and battery design. By virtually validating real-world loading conditions, risk of costly downstream rework can be dramatically reduced. Larux includes an action item for validation as well. 3D Lean automatically populates those tasks from the team Scrum board into an action board, sitting in the pending location, ready to be officially assigned. These are moved to the appropriate timeline range and assigned, notifying everyone attached to the task. End dates and detailed description can be authored in as well and sent off. Larux repeats this process for the remainder of the pending items. With the initial project plan kickoff, each item has been officially documented and assigned. Of course, as the project goes on and grows in complexity, the 3D Lean board and project task will be revisited to review additional needs. This was just a first look at the project planning capabilities available through the 3D Experience platform, directly integrated into an agile Lean board. This approach helps to keep team members focused, gives a centralized location for all tasks to be created and tracked, along with collaboration future requirements. With the initial project plan assigned, it's time to get to the design work. Ankit will take on a series of activities to help him complete his objectives on time. The frame will need to accept the current specs 4-cell battery cutout and be ready to pivot to a 3-cell options. Manufacturing will require a full bill of materials of the shipped assembly, creating the entire virtual twin in a simple operation with SolidWorks assemblies. And with the looming 3-cell option, we will see how Ankit built in proper design intent to automate the updated requirements. The complex frame geometry with the slot for the motor can easily come alive in SolidWorks from data to bill of materials. Today, we will jump straight to the results that Ankit was able to obtain using surfacing tool available in 3D Experience SolidWorks Desktop that will be the focus of another webinar. When done with the frame design, Ankit opens his session inside of SolidWorks that is connected to the 3D Experience platform. This save will move his design to the cloud, making it accessible to the rest of the team. Once the save option is completed, Ankit also unlocks the design. This simple operation allows others in his team with similar credentials to open and edit his designs if needed. The initial geometry of the bike frame is completed. Let's see Nkit accommodates the 4-cell lithium-ion battery. Back in the 3D Experience SolidWorks, Nkit uses its task plane to run a quick search. No longer are days of network directories and confusing folder structures. The results are returned with all the contents on their cloud storage. A thumbnail and relevant metadata steer Nkit into the right direction. A drag and drop is all that's needed to move the data locally to start his design work. But before diving in, Nkit adds a revision to his frame, giving a safe place to roll back to. Some revisions comments are added, and revision B is created. 3D Experience SolidWorks does give an option to immediately work on the latest, but here we see what an out-of-date revision would look like. No problem. Any revision can be pulled from the cloud with just a right click and select Replace by Revision. A list of current revisions, along with any pertinent lifecycle states, are presented for Nkit to select, and the geometry is updated to the latest and greatest. Nkit will take the ownership of the frame design. This keeps any other contribution from modifying its design, which can cause costly and time-consuming errors. Nkit will leverage the existing 4-cell battery to reference for the cutout. Starting with an assembly to put the two together is a great place to start. The frame is placed into the assembly. Nkit also manually enters a name for the assembly. Nkit is using a shared collaborative space on the 3D Experience platform that is visible to all other members of the team. Those spaces are great ways to keep data organized for projects and add another layer of security to the files. The data is saved, locked, and all revisions are up to date. Another search to locate the 4-cell battery, which is recalled from his search history. From the search result, the battery is brought directly into the assembly with a drag and drop. Nkit leverages breadcrumbs to directly select a reference place of the battery unit. Selecting a second reference place, SolidWorks Intelligent Mating identifies the most likely constraints to be made. Here, creating a series of coincident and instance mates help position the battery into the frame. With the battery positions, Nkit can now directly edit the geometry of the frame. We'll now jump to the results. The battery case and frame geometry can be left as separate bodies and divided into the new files, or in this case, merge as a single asset, as they plan to build this as a composite frame. Nkit saves the design changes to the frame and opens the assembly originally created to see a perfect fit of the battery. With the 4-cell battery cutout completed, it's time to assemble the bike with all of the to-be-assembled components. The assembly process in 3D Experience SolidWorks is boiled down to a few simple operations: search, drag, and mate. The first critical component looked for is the motor, making sure it will properly fit into the cutout designed into the frame. Nkit continues to search, drag, and mate all of the additional components specified for this build. Each component gives vendor information, and all the approved components are visible to Nkit. With the final bike assembly completed, it's ready to say to the 3D Experience platform. Let's see the design update. Here we are updating the battery. Select See Revision from list. Right-click on 4-cell battery and replace components. Browse the components from 3D Search and select 3-cells battery, making sure downstream modifications are controlled through proper versioning and involve little redesign efforts. Lock the file and save. Unlock the file. In this way, the free cell battery is updated. So, connected design step is completed. Connected design with 3D Experience platform, Glyphs cloud-based storage, out-of-the-box data management with intuitive design user interface. Let's see next steps.
Once Ankit finishes his design task, the next step is to proceed with the virtual validation of the battery. Taylor Barry is a simulation engineer specialized in the usage of SolidWorks simulation. In this case, the target of the analysis is to validate the battery, checking its thermal performances and the mechanical resistance in case of a drop test. Taylor Barry logs into the 3D Experience platform, opens collaborative task, and select the task assigned to him by the project engineer LaRue, and change the maturity state to in work. Basically, it means the activity has been taken in charge, and saves the task. Now you can see the task is placed on the In Work tab in the middle of the screen. Taylor opens SolidWorks. On the right of the screen, there is the connection with the 3D Experience platform, where Taylor can look for the battery to simulate. He drags and drops the battery into SolidWorks and selects the drop test simulation icon into the SolidWorks simulation menu. Now there are all the steps of the analysis setup. Here, Taylor is going to apply the material to the batteries component inside SolidWorks simulation. Select component interaction under connection. Define the mesh setup. Define the drop height to perform the simulation. And then runs the simulation. When the simulation is done, it's possible to animate to verify its physical behavior. In particular, these stresses aren't propagating to the battery structure, and the component can be considered safe. To save the results on the 3D Experience, Taylor selects the battery from the 3D Experience panel, and then selects the rainbow gear icon in order to save the simulation in the 3D Experience platform. In this way, the data of the simulation can be accessed by all the other product stakeholders in the cloud's environment. Now, Taylor proceeds with the thermal simulation inside SolidWorks. He starts to define materials for the components of the battery's assembly. In particular, here, Taylor supplies the material to the cover part of the battery. Now, he can select the thermal loads, and in particular, the heat power, and applies it to the battery's cells. Then he applies convection value to the external surfaces, and in particular, convection coefficient and the temperature condition of the environment. Applies mesh and runs the simulation. In the post-processing, he can display different kinds of contours to check the thermal performances. For example, here we can see the heat flux chart. This way, the thermal simulation is done. Going back to the collaborative task app, Taylor uploads the thermal simulation reports as attachment to batteries design validation task. In this way, the report is going to be always linked to the task and will help the project engineer to track the activity. Taylor writes his positive feedback in the comment section of his task. The project manager LaRue received a notification on her platform. And she's able to review immediately the report, providing a feedback to Taylor. As everything looks okay, Taylor can change the maturity state to completed. And then close the task. In this way, the task moves to the complete tab on the right of the screen. So the phase that we call connected design is completed with the help of Ankit and Taylor. Basically, it allows to validate design with simulation directly in SolidWorks. In addition, the other great benefit comes from the collaborative nature of the platform that allows the project manager LaRue to review all changes and updates related to design in real time. So we can review some of the main keynotes here. SolidWorks is a useful tool to design and simulate in a user-friendly environment. It benefits of the connection to the 3D Experience platform that enables the possibility to store all the data on cloud. The integrated simulation tools in SolidWorks helps to drive the design, reducing the number of physical prototypes and speeding up the product development. So we saw that the design engineer made two designs for the battery, the 4-cell battery and the 3-cell battery. Aside from the battery, there are also two corresponding designs for the bike's frame. The next step of the project is to validate the bike's design in its working condition. As the bike during its life is going to face cyclical loads, it is necessary to pass a durability analysis. The durability simulation will be performed by Salil Gupta, a simulation engineer using the 3D Experience platform. In particular, we're going to check the interactions that a simulation engineer has with its teammates and the workflow of the analysis of the 3-cells battery frame. So here we are in the collaborative task space. Right now, the user is the project engineer, Laru, that received a notification from the designer regarding the frame's design that has been completed. Laru is going to review the design with the widget 3D Play. The 3D Play widget is quite useful as enables to the user of the platform to have a light 3D preview of the CAD files. In particular, she's going to check the dimension of the housing to correctly place the battery. After the review, she gives a feedback to the designer inside the task that has been originally created. As the designer task is completed, to proceed with durability simulation, Laru involves directly the simulation engineer that is going to receive a notification in his platform. Then she closes the designer task, changing its maturity state to complete. Here, there is a quick drawing showing the cyclical loads that are going to act on the bike's frame during its working life. In particular, the two forces coming from the wheels are going to be very demanding for the life of the component. In this example, Salid has already performed the first validation with the 4-cells battery frame. Now, he wants to replace the original frame with the new 3-cell version provided by the designer, keeping the same simulation setup that he originally used. Salid opens the CAE analysis. In the upper left corner of the screen, you can see the simulation tree that involves 3 macro areas. The models, where basically there are geometry and mesh models, scenario, where the physical conditions are applied, and the results, where the post-processing is made. From the model section of the simulation tree, he opens the geometry in the new app. Notice that the tree has changed now, as Salid is in the app dedicated to the model and mesh creation. He proceeds to replace the geometry with the new revision. He selects the revision B1 from the window, and you can see the geometry updates as B1 version as a shorter housing. Here, Salid came back to the original simulation, but the geometry now shows B1, so the replacement has been effective. Then mesh is going to be updated, and Salid makes some quick visual check to the section tool. Then he proceeds to the scenario section of the tree. Basically, here you can see the setup doesn't need any update as the loads and constraints are automatically applied to the replace geometry. Using the feature manager tool, it is possible to review and to modify in a unique environment all the setup of the analysis. In this case, there are 3 steps with 3 different load conditions. These steps are the inputs for the durability analysis that is going to make them cyclical and that going to combine them. Basically, in this screen, it's possible to define some parameters that describe the cyclical load. Before starting the computation, Salil checks the simulation settings. In this case, the assistant wizard provides a quick visual confirmation with some green checks. But the assistant wizard can be used also during the setup phase of the simulation in order to guide the user into the process. Completing these checks, he performs the simulation and proceeds to the post-processing phase. There are multiple options to visualize different quantities as solvency stresses, displacements, forces, and so on. In this case, the interest is for the number of cycles that the component can withstand. So the red locations are where there is the lower life and higher risk of breakage. It is possible now to compare the two designs with the compare results tool. The usage is quite simple, as it's possible to choose how to split the screen and simply drag and drop the variables that the user wants to compare. Comparing the two designs side by side, it can be seen that there are some differences between the two designs, but the minimum number of cycles is still above the target. There is the possibility to plot not only the life, but also other contours, like, for example, displacement in this case. Now that the simulation has been completed, Salil can provide the feedback to the team into the collaborative task section of the platform. Salil opens the assigned task and provides a quick comment highlighting the final results of the simulation. Then he selects the durability simulation file and drags and drops it into the deliverable section and saves the task. In this way, the results are linked directly to the task and can help the project engineer to keep track of the activities. In addition to that, it allows also to all other stakeholders to check the simulation results directly on the 3D. This concludes the engineering durability validation. Let's analyze some of the keynotes that we had. The virtual durability validation done by the Experience platform could improve the product development, as it makes possible to analyze a complex phenomenon like fatigue. This feature allows also to reduce the number of durability experimental tests that are long and expensive. So it allows to reduce the cost of the product development and to speed up the time to the market. Last but not least, the collaborative nature of the platform makes it possible to quickly and easily share simulation results with the projects and product stakeholders. To highlight this last point, let's shift the perspective on the project engineer side. Now that the analyst has finished the task assigned to him, let's check what Larue is able to see in her platform. Into the collaborative task app, Larue opens the task assigned to Salil. Aside from comments, users have some other options to interact, similarly to what you can see in the typical social media platforms. For example, in this case, she provides a like to the Salil comments. As you can see, Larue finds the results file immediately inside the deliverable section of Salil task. Then she drags and drops the touch simulation from deliverables in 3D Play to review the result directly on the 3D model. She checks the minimum log of life value. And as everything looks safe, she provides a feedback to Salil. After that, she tells Salil to proceed with the next step of the product development that involves an explicit simulation of an impact, and close at the end the Salil task. In this step of the product development, Salil is going to perform a crash impact simulation. As it involves a quick physics phenomena in which inertial effects are quite important, the Abacus explicit solver is the most suitable solution for this kind of simulation. In general, this solver can be used in all the scenarios where inertial effects aren't negligible or that involves high level of nonlinearity. Now, if you remember, we saw previously that Taylor performed a thermal simulation of the battery using SolidWorks simulation. When he finished the analysis on SolidWorks simulation, he saved the simulations file inside the 3D experience platform. In that way, he allowed to the other users to access directly the data inside the cloud. Sahil now is going to take advantage of that, as he's going to use the SolidWorks simulation file to recover the mesh of the battery. So Sahil opens SolidWorks simulation file in the experience platform. He selects mechanical scenario to open file. Mechanical scenario is the app that gives access to the experience solvers and in general to the most advanced structural simulation available on the platform. He selects the pre-mesh data of the battery. Then here we can see the mesh of the battery has been imported into the assembly. Now we can see the complete meshed model. He sets the initial loading condition, in this case, the velocity. And from the system wizard, he selects model and scenario check to verify the simulation setup. He runs the checks, and once it's complete, he can run the simulation. The simulation is run on cloud in this case, as the crash simulation is quite expensive from the computational point of view. He can select the number of cores to run the simulation, and in this case, he uses 144 cores. There is an option to keep the previous results in order to make a comparison with the new one, as we did, for example, for the bike's frame. And after some time, he gets the results. In the post-processing, we can view how the load is transferred from the front wheel to the rear wheel. In this way, Sahil completes the dynamic validation. Let's highlight some keynotes here. The Abacus explicit solver can be very useful to simulate fast physics phenomena and high nonlinear problems, where the implicit solvers could fail. In addition, we also saw the possibility to run the simulation on cloud. This option isn't limited to the explicit analysis, but can be used in other situations. For example, with implicit solver also, large assemblies, and in general, when the local computational resources are limited for the simulation that we have to run. So let's proceed with the last physics to analyze electromagnetics. On the 3D experience platform, there is an electromagnetics package that is going to be used by Salil to design an electric motor. The electric motor has to reach technical requirements of efficiency, torque, and noise. Salil saves motor from SolidWorks to platform in order to perform the virtual analysis. Salil logs in the platform and opens CST Studio Suite app. He loads the required material from library database and assigns them to the parts. He defined magnets and the permanent magnets. Then he creates coil from solid by defining parameters like number of turns. Now he defined rotation motion parameters about the rotational axis and defined the boundary condition and local mesh properties for the air gap region. He created a mesh that is finer in the air gap region. Eventually, Salil modeled multiple configurations of coil, magnets, and core materials to compute the torque efficiency, the torque ripple, and the torque against angular velocity. The performance trade-off app allows to compare immediately different designs and identify the best configuration that reach the targets. With the simulation-driven design approach, he came up with a motor which is smaller and lighter with a small loss in maximum torque. Design A has higher nominal torque result, as you can see from the maximum torque versus speed graph. The torque ripple in relation to the average torque should be as low as possible to make machine run smoother and quieter. Other plots can be shown as, for example, the good efficiency region. And also magnetic flux line can be virtually analyzed. This ends the electric motor design phase. Let's highlight some keynotes related to the electromagnetics engineer package. It allows to analyze electromagnetic response of entire systems. It allows to identify possible technical issues directly in the virtual environment before going to the prototype phase. It could use the collaborative nature of the platform to share design updates with other team members.
Let's see the project competition phase. Brody logs in into the platform. He searches electric bike from 3D search. He drags and drops in engineering release widget and then in 3D play. He selects frame and select replace by revision. He selects C1 revision. Existing frame is replaced by C1 revision. He refreshes 3D Play widget to view updated changes. After refresh, we can see updated frame in 3D Play. He selects battery assembly. He replaces existing battery assembly B1 revision with C1 revision. Updated battery assembly is visible in 3D Play. Brody searches electric bike in 3D search and drags in compare widget. He opens electric bike revision to compare. He selects electric bike B1 revision to compare with revision A1. He selects compare. All components are opened from both revision with visualization. He selects frame to see changes in both frame with colorization. He selects battery to see changes in both batteries with colorization. In this way, project completion step is completed. The product release engineer is able to ensure consistent product quality and check the alignment among multidisciplinary engineering product definition processes and company strategies. We have seen how to collaboratively tackle those challenges with the support of the 3D Experience platform. Connect, collaborate, create are all made possible through the 3D Experience platform by joining the best-in-class technologies to bring a unified solution. Thank you for staying with us today.